In 9.6, we're going to learn more about the specifics of polymorphism. There's really two key notes here. So this one talks about what we have a declared type. And in this note here, it talks about the actual object type. So I'm going to try to explain the difference in those two things and their impact on polymorphic behavior. So if we take a look, see this word here, correctness. Sometimes you'll hear me say like legality. We're talking about what kind of method calls can you make without causing an error. And then here it talks about the actual object type saying that it's executed. So that's kind of often referred to as the implemented behavior. So like what's it actually going to do? And then if we look at this line of code right here, 39, on the left side, we have our declared type. Okay. So when they use that phrase, they're looking at this here saying lightning thief as a variable has been declared as type item for sale. Okay, so in this line, my declared type is item for sale. Okay, and then over here on the right side, this is my actual type. This is the reference being made. So this is what we're referring to as the actual object type. And in this case, it would be a book. So, all right. We've got a reference of type book that's being constructed, but it's being held in a declared variable of type item for sale. So the last section of notes told us that that's okay, you can do that, right? And then that kind of facilitates an easier way to transfer these objects through method parameters, store them in our data structures and things like that. But there are some consequences. Okay, so what are those? Well, this reference is going to point to the item for sale class when retrieving things like methods and instance variables that have been referenced through it. And in the item for sale class, there's really just a couple of methods. There's get title, there's get genre. We've inherited toString and then done an override on it. That's all that an item for sale can do. If that's all I want to do, it's really no big deal here. So for example, let's say I have a print statement. And in this print statement, I'm going to use the item for sale lightning thief as my reference. And from that reference, I could call those methods. So for example, I could call get title. This book has a title called Lightning Thief. And then let's go ahead and I'm just going to put in a blank line on each end of it just to kind of stand it out a little bit. All right, so let's see what happens if I run this. It's going to point to that class item for sale because that's the type of the reference. It's going to find that method in there. And then it's going to run it. And title got initialized because we made that call to super from the constructor of book. It passed up the title. It was the lightning thief. And there we go. Okay, no problem, right? I could do the same thing with get genre. So if I came in here and I ran the get genre method, it would do the same thing. Okay, it would run and everything's fine, gets YA. Here's where I'm going to get into some problems. Okay, and this is something we got to watch out for with polymorphism. In addition to titles and genres, books also have authors and publishers, and they have accessor methods for each. However, if I call either of these methods, either get author or get publisher on Lightning Thief, I'm going to get an error. The reason I'm getting that error is not all item for sale have that method. Only books do. Since we're holding it in a broader, more generic type, Java doesn't understand that it's actually holding a book. At compile time, it doesn't retrieve what's actually being held in that variable to check it. It just looks at the declared type for legality. So if this is your declared type, it points you to the item for sale class to find methods that you can do. It doesn't understand to look in book. Remember, you don't inherit up, you only inherit down. So like book inherits from item for sale, but not vice versa. If I wanted to run the get author method, I'd have to be holding this in a book reference, in a book type. So if I had declared Lightning Thief as a book, then I could run get author on it. But if I have it declared as an item for sale, like I did a second ago, I'm going to go back to that error message. Same exact thing is going to happen if I put get publisher here. Okay, it's going to point to the item for sale class. It's going to look for it, can't find it. If I wanted to do this, I'd have to run it from the book class. All right, so what about the toString method? Well, why is this different? Well, here's the difference. I put an override of toString in the book class and in the item for sale class. So this is a legal method call because it will look to here, item for sale, find the method. So the declared type points to a class where that method can be found. It would have been inherited from object too, but here it is, okay? But at runtime, after you've passed the compiler check and there haven't been any errors identified, now you're into the running of the program, it actually retrieves the actual object type, which was a book. That's the type of reference that we actually build and put in that variable to be held. So now that's where it goes for the implementation. So there's going to be a subtle difference. If it had gone to item for sale, it only would have printed title and genre. I'm predicting it will actually go to the book class where it will still print title and genre from the super, but it's also going to add info about the author and the publisher. That wouldn't have been there if it ran the method from the item for sale class. So the fact that I'm getting author and publisher information verifies to me that it came from here. It came from this super toString. It did not come from the item for sale toString. Then it wouldn't have included author and publisher. Okay, so that's the difference between Java's compile time check, which just determines what it is capable of doing, and then its runtime execution, which is where it actually implements the code and decides what to do. It has to be legal, yes, but the runtime can revert back. Now, this is only an issue when we have an override. Earlier, when I was doing get title, get genre, this wasn't a big deal because I was just running the methods off of inheritance. But the toString method was actually in both locations. There was an override, and I had to pick which one to run. I didn't have two get title methods. I only had one, so it wasn't an issue. I have two toString methods. I had to pick which one I wanted. We could also see this pretty well here in this ebook example that I have. Okay, so right now I have a declared type of ebook, and I have an actual type of ebook. So there's really no issue right now. If I run this, everything's fine. I'm not using any polymorphism. So right here, I could use that ebook to call get title and get genre, even though if I go into the declared type ebook, I don't see those methods. I still have another chance. Maybe they come to me from the book class. So I go to the book class. Well, I still don't see get title and get genre, but maybe they come from the item for sale class, and that's where we locate them. So they've been inherited to book and then inherited to ebook. So those are legal method calls. I will not get an error message from lines 53 or 54. Okay. And I won't get any error messages here either. So get author is available to an ebook through inheritance, even though it's in the book class. Okay, we've extended that. And then get file size and get publisher are actually both in the ebook class. So we could run those also. Well, let's put some polymorphic behavior. Okay, so let's make this a book instead of an ebook. One of those method calls is now going to cause an error. It's the one on line 60. So let's see why that is. So this one right here, I'm going to have to comment out if I want to run this code. It says right here, line 60 is an error, okay? And that's because if we point to the book class, there's no get file size method. And it's also not in the item for sale class. And we don't inherit from subclasses. So if it's labeled as a book, it can't call that subclass method, okay? It wasn't an issue a minute ago because I had the declared type as ebook, so it was pointing to the class where that method was. Let's comment that line out. Now if I run it, it should be legal, everything should be fine. Now we're going to run into a little issue here with this get publisher method, though. It's kind of interesting. So right now, let's take a look at which one. I'm printing it down here below S8. and it's right here. Okay, notice it said Disney Press E version. Well, this only says Disney Press. So where did the E version come from? Well, that's because in the ebook get publisher method, I printed that extra little string there, E version, okay, because it came from an ebook. That wasn't in the book class. If you called the get publisher method here, it wouldn't have done that. So again, here's kind of the steps that Java went through. This is tricky, but Java said, okay, can a book call get publisher? And the answer is yes. A book can call the method because you can look in the book class and find the method. It's publicly available, use the correct signature, all that stuff. Okay. Same things we learned about in chapter 2. So it's a legal method call. But at runtime, since it was actually an ebook, it ran the method from here. It followed the override, which is that's what we thought it would do. That's what the notes tell us. Okay. And then if you wanted to take this even further, you could make this an item for sale. What that would do is, again, kind of like we saw a minute ago, I'd actually get error messages now from 59 and 61 as well, because now I don't have a get author or get publisher method available to me. Okay, so that's why I'm getting those error messages. And you could try playing around some more of these here. I've put in some suggestions that you could try, see if you can follow through with those, and hopefully you'll learn some more stuff about polymorphism along the way.